Good day, everyone. In our today's class, we are going to look at question under work, energy, and power from in physics. Now, the question says a 500-gram block slide across a smooth plane top with an initial velocity of 4 meters per second and come to rest in a distance of 8 meters. The question has to find the average friction force that retarded its motion. Now, look at the question very well. To solve, remember, as you always do, you write solution. Now, the first thing, let's identify from the question the parameters that are given. Number one of the parameters that are given is the mass of the block. So that will be what? M, let's make it MB, that is mass of block. And that's going to give us what? MB, and that's what? 500 gram. And to kilogram, that's going to be 500 divided by 1000. And that's going to give us 0.5 kg. So the question says a 500 grams block slides across a smooth plane top with an initial velocity of what? Of 4 meters per second and come to rest in a distance of what? 8 meters. Now, if you look at that question very well, so we are given initial velocity. Let's say initial velocity V of I is equal to 4 meters per second. Now, the block comes to rest in a distance of 8 meters. Now, in that question, the block comes to rest, meaning the block attained its final velocity, which is 0. Final velocity, let's make that one to be V. Final velocity, which is what? Is 0 meter per second. Now, at a distance of what? It attained this velocity of 0 meter per second at a distance of 8 meters. So S is equal to 8 meters. So the question asks us to calculate the friction. The question says find the average friction force that retard its what? Its motion. That is the frictional force that exists between the block and the plane and the smooth plane top that brought the block to what? To rest. Now, that's what we are asked to calculate. Now, to do this now, I want us to produce a simple illustration just to back the explanation I'm trying to provide. Now, so let's say this is the smooth plane top they mentioned in that question. So let's say this is the block of 0.5 kg mentioned in the question. Now, I want us to take note of something. Remember that this object is moving with an initial velocity of 4 meters per second. Now, if this object is moving, meaning the object is having kinetic energy. Now, the question says the object moved with this velocity and the object retarded due to frictional force that exists between the block and the surface. Now, if this object is moving in this direction, remember that the frictional force will be moving in this direction. Now, there is something I want us to take note here in this question. Now, here in this question, if this object is moving in this direction with an initial velocity of this, the question says the object is brought to rest after undergoing a distance of what? 8 meters. Now, meaning there is change in what? Kinetic energy during the motion. Now, what brought the object to rest is the frictional force. Is the frictional force that exists between the what? The block and the surface. Now, both the objects now in this direction. Now, this object now, if you look at this is the direction of this object. Is moving like this positively. Are you getting my point? Now, what happened? The force that is to bring the object to rest, which is the frictional force, is moving in the opposite direction. Meaning the angle that exists between the movement of that object, the direction of that object, and the force, which is the frictional force, the angle is 180. That is, since it is moving on a straight line, then the angle is what? 180. Take note of that, because we are going to use that in this question. That is, angle noted out here from that illustration to be what? 180 degree. Now, let's come back to this. If you look at this question very well, it is frictional force that we are asked to calculate. Now, it is very simple. Now, remember that the change in kinetic energy of the block will be equal to the work done on block by friction force. Now, what I mean by that is this. Look at this block very well. This block is moving in this direction, right? Now, there is change in kinetic energy of this object. Let's say this object initially like this. Now, when it comes to rest, let's say the object is now found here. Now, as at this point, this object is not moving again at this point. Do you get the point? It is not moving. It has come to rest here. Meaning there is a change of velocity from here. This is the initial velocity. And when getting to here, the velocity has become what? Is 0. Has become 0 meters per second. Are you getting what I'm saying? Now, so the change in velocity of the block. Are you getting my point? The change in velocity of the block help us to know that there is equally change in what? Kinetic energy of the block. There is change in kinetic energy of the block. Let me put it like that. Now, the change in kinetic energy of the block from here to here to the retarded point now is equal to the work that is being done by the block. It is equal to the work done on the block by the friction. Now, what I mean by that is this. Now, the object changes from here to here. Are you getting my point? Now, the kinetic energy changes from here to here. Now, there is a work that is being done on this block. And what does the work is what? The friction. And what was the work of the friction there? It only brings this object to this rest, to this point. Now, let's continue. Now, having known that this friction, it takes this friction a serious work to bring this object to rest. Now, the work done by that friction on this block is equal to the change in kinetic energy of this block. Now, therefore, change in kinetic energy of the block is equal to work done is equal to work done on block by friction. by frictional force. Now, change in kinetic energy. Remember, formula for kinetic energy is half m v square. This is going to be final velocity, while this is going to be initial velocity, and that's equal to work done. The work done is equal to F. In that regard, the force here, remember, work done is equal to force times distance. Since an angle is involved, then to the work force times distance cos what? Theta. Remember that this force here is the force required by the what? Is the force of the what? Friction that acted on the block in order to bring the block to what? To rest. So that's going to be F of F times what? X cos what? Cos theta, because there is an angle between the moving block and the what? And the opposing force. So since they are moving oppositely to one another, then there is an angle, and that angle is equal to what? 180 degree. Now, at this point now, your final velocity, remember, if it is 0, you have this to be m times the mass is still the same thing as 0.5 times what? Is 0. And at this point, you are going to have your m is still times 0.5 times the initial velocity, which is 4 meter per second, then this is square. 4 meter per second square. That means when you replace v with 4 here, it will be v raised to power 2, and that's what? 4 raised to power 2, which is equal to, your force is what you are asked to calculate. What is your distance? It is given in the question to be what? 8 meter times the what? The cos 180. Remember, I said the reason why I use this 180, the force that is to bring this object, the frictional force that is to bring this block to rest, is moving oppositely to the direction of the motion. So in that regard, the angle between the force and the direction to which the object is moving is 180. That it is a straight line, then it is equal to 180, angle on a straight line. So when we replace it with this, we are going to have this to be, because remember, all this will be what? Is 0. Then you'll be left with what? This minus 1 over 2 times 0.5 was 4 raised to power, that's 16, is equal to F, that's frictional force, times 8. Cos 180 is equal to minus 1 when you press your calculator. So 2 will cancel 2, you have what? 8. You have minus 0.5 times 8 is equal to, when you multiply F times 8 times minus 1, you are going to get minus 8F, that is frictional force. Now minus will cancel minus, you are going to get, so let's multiply 8 times times 0.5 times 8. 0.5 times 8 is going to give you 4, is equal to 8F. Therefore, you are going to have your F to be equal to 4 divided by 8, and that's going to give you 0.5 Newton. Now, simple. This force is what is being this is the force that exists between the block and the surface to bring this object to what? To rest. To reduce this velocity of 4 meter per second to what? Is 0 meter per second. The amount of force put in by that exists between them that brought the object to rest is what? Is 0.5. Thank you, and don't forget to subscribe to this channel. In case you have question to ask me, you can drop it in the concerning this, or you want me to solve a question from any topic, or you want me to treat any topic, you can also drop it in the comment section. So please don't forget to subscribe to this channel. It is very important, because that is what will keep the energy in me, That's what will make the energy in me to still be growing, because as soon as I see that people are enjoying the class, I will surely keep on doing more in order to encourage my viewers. Thank you once again.